Welcome to SGSTEM Talk and Trivia. Our host for you today. My name is Marcus, and this is...
Hello guys, I'm sorry, I forgot it was supposed to be my cue. Hi guys, I'm Kellen. How's everyone doing?
Yep, we're lucky to have Mr. Tony O'Dempsey from the Nature Society of Singapore sharing with us putting the art back into cartography. So this is a very clever title. So Tony's one of the best mappers I've known. I've known him since I think 2008, and he's a GIS expert. And all the maps that you see in NSS publications, especially the public domain, a lot of them are made by Tony, and he's very good at showing spatial information and drawing attention to certain details. So it's really an art and a science in doing that. And we'll let Tony tell us more about his expertise and what he'd like to see for GIS maps in future. So Tony, please.
Okay. Can you hear me okay?
Yes, we hear you.
I'm trying to share my screen now.
Yep, I'll just stop mine. Yep, then you can share yours now. It should work.
Okay. Let me see. Share. Keep getting these messages up. Okay. I think that you can see it okay now. So good evening, everybody, and welcome to the SGSTEM talk. Tonight I'm talking about, I keep getting these messages covering my screen. I hope you can't see them. Tonight I'm going to be talking about let's put the art back into cartography, which is something I feel quite passionately about. And I'll reveal why as we move along. The converse to that, of course, is, I'm trying to change, the converse to that is who took the art out of cartography. And some rat came along and grabbed the ART out of cartography and left us with cography. So there are many cographers producing lacklustre maps out there, and there's a reason for it. I'll just go to the next slide. Okay, so back in the sorry, I'm getting distracted by all these messages keep coming up from Zoom because I'm a host on this program. So every time somebody comes into the room, I get this message, let me in. Okay, so way back in the 12th century, that our first piece of map that we have that we can put our hands on. We had maps long before the 12th century, but none of them have survived. And some of the early ones are, you know, from the 12th century, and they tended to look like this. There wasn't any systematic system of drawing the map with respect to the relationship to the Earth. They're all very approximate, and there was always a lot of extra artwork, and quite often the artwork overwhelmed the general geographic content of the map. Oh, sorry, my mouse is not working properly here. So one of the things that they often did in those old maps, you'd see a lot of artwork, and for example, here some elephants, they're being used to fill in a blank space and might be typical of the land that's being depicted. I hope that we can steal some of these ideas and start implementing them in our modern maps. Here's another example of an early map where you have you know, a sea serpent here. The sea serpent is actually feasting on some sailors. The seamen, he likes to eat the seamen. And there's a whirlpool over here, so they're warning of danger by drawing a whirlpool. And there's other decorations around the place. And a lot of the things that are on these maps are influenced by a lack of knowledge. So they had a lack of knowledge about what was in the sea. They had a lack of knowledge about how big the world was and what shape it was. And a lot of these creatures that they drew were mythical creatures. Sailors come back from trips and tell these big, long grandfather stories about what they saw, and the story gets better and better. And then the people who annotate the maps tend to draw, you know, their impression of what the people saw. So you get these ghastly looking animals filling in the blank spaces. Here's some mermaids. That's a whale. I have another slide here. I'm just going to go through these fairly quickly. I particularly like this one because of the expression on the faces of the whales, and they're throwing over the cargo to try and appease the whale's anger. Taking note of ripples in the water. Okay, so how did you depict something that was sitting on a surface of water? Sometimes we need to map surfaces of water in our maps, and you know, we can do things more than just having a polygon fill of the water in blue. You know, we can around the edge have ripples, or we can put things in the water and put ripples around them, and it just adds to the quality of the map, to the look of the map. There were also Christian influences, because back in the day when the Portuguese and the Dutch were out, you know, exploring the world, they had strong Christian influence. And of course, this is a scene depicting Jonah, which is one of the prophets, one of the minor prophets. His story appears in the Jewish scripture, the Christian scripture, and the Islamic scripture. And the deal is that Jonah was being sent to some place by God to ask the people to behave themselves. He didn't want to go. He asked the boatmen to take him somewhere else. God became angry. A big storm came. Jonah realized he was the fault of the storm, and he asked the boatmen to throw him into the water. So Jonah was thrown into the water. He got gobbled up by a whale. He spent 3 days in the belly of the whale. And then you'll always see a second map. After 3 days, Jonah was vomited up on the shore. When you see this map, when you see this image on a map, you're going to look around, you're going to find that one too. That's the story of Jonah appearing in the map. I think it's interesting that these sort of things appear on the maps. Go to the next one. Here's another example of, you know, why should we just produce a boring old map of whatever we want to display, however, but any of the blank spaces around, you can put all this stuff that serves no function to the map. The winds, the girls blowing the wind, okay? It just adds to the balance of the map. And here's some other zoom ins of the monsters that appear. This one's eating a man, and this fellow here is running around naked, so I had to put a fig over his genitals so that the people would not be offended. And here I'm moving on a bit. So I've just gone through a whole bunch of very old maps that come from, you know, the Renaissance and the Middle Ages. Now I'm coming up to some more modern times, the 1950s, and this is a Swiss. There's some Swiss maps from Swiss Topo in Switzerland, and the cartographers sometimes can be a little bit naughty, and sometimes they hide things in the map's symbology. And there's a polar bear here, and over here you have a fish, and here you have a mountain climber. Of course, Switzerland, you know, you have all these Swiss Alps and the mountains. And it's very interesting that the management of these organizations generally consist of people who were cartographers and who have moved up in seniority to the point where they're the head of the agency, and they just turn the other way when cartographers put these things on the maps, because they themselves used to do it. So it's a tradition in cartography to put funny things on maps, and sometimes you don't see it unless somebody points it out to you. Here's some even more modern ones. Now, I used to work in the Queensland Forestry Department. S&M stands for Survey and Mapping. Not what you're thinking, Uncle Nick. S&M branch, Survey and Mapping branch of Queensland Forestry Department. And my colleagues, who were, you know, maybe a generation older than me, were doing these sort of maps in the 1980s. In the 1980s, I was a junior cartographer. I was a young whippersnapper. And my seniors were doing this sort of thing. So here's a boat being put onto the map. Here's an aeroplane taking off from an airstrip. That's one of my colleagues. His name was Lionel. So he puts a Linus there. So you can see the logs floating down the stream. All these things get snuck into the maps, and they just come through and get published, and you know, people just have a good laugh about it. But I think it adds character to the maps, so personality. But aside from the artwork, you know, the artwork is very important. And the artwork is more than just, you know, the polar bears and the monsters and this sort of thing. The art is also how you symbolize the map, how you present the data in the map. And later we're going to look at that aspect in a bit more detail, but there's also science involved, or I think a better word would be applied science, because in this sort of endeavor, we're taking technologies that have been developed by other people through a scientific process, and we apply them. Okay, so one of the ones I want to highlight is the problem of longitude. Back before the middle 1700s, we had no way to properly determine the longitude of a ship at sea. We could determine latitude, but we could not determine longitude. And quite often that ended up with people getting blown off course east or west of, and becoming lost and then crashing into rocks and sinking and people dying. So longitude was a serious problem in the early days until Harrison, and it's a very interesting story about this guy Harrison, who made the first seagoing clock. Of course, the clocks of the day all had pendulums, so you take them onto the sea and they just don't work anymore because the ship's rolling around. So he made the first clock, H1, in 1736, made of wood. It kept time fairly well, and he fine-tuned it to the point that by 1759, he had the fourth version of his clock. It was, as you see here, this exists, and it's one of the clocks that Captain Cook took on his third or fourth voyage. I think it might have been the voyage to New Zealand. He had this clock with him. So Captain Cook was able to, determine longitude quite accurately. He was one of the first ones to determine longitude. Of course, when we're doing maps of the world, because in this, in those days, in the 18th century, in the 17th and 16th centuries, it was a time of discovery. New continents were being discovered, and we needed to be able to map the world properly. So that was an aspect of science that we adopted in map making. That was very valuable to us. Excuse me, Corona. I think that tonight I'm just throwing ideas out. I'm not going to teach you anything because there's not enough time to actually go into things in great depth. So there is a method for determining longitude that I'm showing here, that you carry a clock on the ship. So here's the ship and here's the clock, and the clock is set to the Greenwich time, and it keeps Greenwich time for the whole voyage. And then you compare when the sun crosses your meridian, or when a star crosses your meridian directly overhead, you note the time in Greenwich, you note the local time, because you can work out the local time from the sun position. And you can, by the difference in time that the sun crossed your meridian, multiply by 15, because there's 15 degrees to an hour, and you end up with your longitude. Very simple. So that was the one of the great things. And then we have the global positioning system. And what I have here is, you might be able to see the GPS satellites here that I put up here. This is a special map projection. This map of Australia is an orthographic map projection, and that's real data on a real map. And I've added stuff to it. So I've got some astronomy software, because astronomy is one of my little hobbies. And I configured the astronomy software to give me a map of the sky looking northwest from Australia on the night that I prepared this. And I caught that image of the stars and I inserted that into my map. So this is an authentic star map sitting behind the map of Australia. And I took a data set of cities of Australia and made them look like little light pricks. And I added a moon, and the moon is not the right size. The moon is severely exaggerated. The moon's not really that close to the world. But in cartography, we're allowed to exaggerate things. We're allowed to manipulate things so that what we're trying to communicate is more clear. And that's what we call cartographic license. So I have a cartographic license, and I'm allowed to do that. And you can always have a bit of fun. So here's a Pontianak. I put a Pontianak in the middle of Australia there. But we don't have any Pontianaks in Australia. All the Pontianaks are up here in Southeast Asia. I don't know why the Pontianaks don't go to Australia. But it's always fun. And my wife told me that I've got to stop putting Pontianaks on my maps, because if I keep putting Pontianaks on the maps, the Pontianak will come to me. So I'm not allowed to do that anymore. Yeah, so there's other, when you're dealing with maps and you're working as a cartographer, or you might be a scientist and you want to produce a map for your paper that you're going to publish, or you want to do some analysis. You have to have some basic knowledge of the sciences, of the geospatial sciences. So we have this issue of datum transformations that cause a lot of problems because a lot of people don't understand them, because you understand datums and geodesy because when you do a surveying degree, then you study geodesy. But if you're a biologist, you don't study geodesy, and you're pulling your data from old data sources and you're integrating it with data that comes from GPS. You can be hundreds of meters out, hundreds of meters between two data sets and not know it, which means you can get yourself into some difficulties. I'm not going to go and drill down into datum transformations. It's quite a mathematical subject and very chim, but it is an interesting subject. And I think that my point tonight would be, the take home would be that you can't just press the buttons on the software, on the GIS software, and come out with the correct result. You have to have some fundamental basic understanding of what you're doing. Otherwise, you can get yourself into a bit of difficulty. One of the problems with GPS is, Australia has tectonic plate movement. Australia is moving northeast at, several centimeters a year. And so if 3 years ago you took a GPS position of a particular thing on the ground, and then 5 years later you come along and take another GPS position, it's going to have different coordinates. So you have to know how to deal with it. Ultimately with Australia moving northeast, my depiction here is what happens when it finally hits America, because you go northeast, the rugged tip of Cape York Peninsula is going to insert itself into the narrow orifice of the San Francisco Bay. And while those people up there are quite used to that sort of thing, I think it would be quite a shock for them. I'm moving on to a thing called map projections now. Map projections are a way to present the spherical Earth on a flat sheet of paper. So here's one of the early maps from Ahmed Muhyiddin from 1500, the 16th century. And you can see that an interesting thing is that the lines on the map, some curved lines, some straight lines. That tells me that he was using a conic map projection, a particular type of map projection. You have to understand a little bit about map projections. Here's the Gerard Mercator. Everybody's heard of the Mercator map projection, because if you use QGIS and you open up, geographic data in QGIS, it tells you you've got a pseudo Mercator projection. What a load of nonsense that is. You have a geographic projection being projected directly onto a screen, not a pseudo Mercator map projection. It even shows that the people who write the software don't understand what, a lot of this stuff these days. People who have no geospatial science are writing software, are writing things like QGIS and ArcGIS. So there's a degradation in the quality and depth of knowledge. Well, anyway, this map that I look at here, it's using a cylindrical map projection. I can tell by the look of it, the lines and that sort of thing. And one interesting thing about this map here, it's made up of individual copper plates. So where my cursor is turning now, I've got a copper plate, one single copper plate. And these guys, they spent years doing this stuff. They'd sit there and one map was years of their life, and they painstakingly engrave these copper plates. Make one mistake, you throw the plate out, you start again, right? So interesting. So map projections. Here's a scientific diagram of the day. Do you think that you would draw a scientific diagram like this today to express something? I don't think you would, but the guy probably spent a year doing this one. And what's it about? It's about demonstrating an orthographic map projection, a stereographic map projection, how we have a geometric relationship between the globe, how we project things on the globe onto the flat plane. So that's what this diagram is all about. I had to deploy the fig again in this case. But in seriousness, we have these different sort of map projections. We can the idea is to use a shape like a cylinder, a cone, or a plane. I think somebody's not muted. Yeah, so we need to have a cylinder. A cylinder can be unwrapped into a flat piece of paper. So can a cone. These are developable solids. And so we wrap to produce the map, we wrap the cylinder virtually around the Earth, and we project onto the cylinder. We end up with, you know, a grid of latitudes and longitudes. A graticule is what we call it, that looks like this. If we go to a cone, a conic projection, the cone is superimposed over the Earth, and there are geometric relationships that projects the lines of latitude and longitude onto the map. It becomes a graticule, is a special word. And so you can see that these maps tend to have particular shapes and looks about them. You can tell by the look of the map that it's a conic projection. For a planar projection, in this case, and the planar projection is just a plane stuck somewhere on the map. Typically, it's used for mapping the poles. So there's some of the sciences, all the mathematics that goes in behind this is very interesting, because we use calculus and we want to, what we do is we set the relationship, whether it be an equal area map or a conformal map, according to what our need is for the map projection, and we set the partial differential of the scale factors equal to each other if we want a conformal map projection. Then we work backwards and derive the formula like that. It's very interesting stuff. A general user doesn't have to know that stuff, but there is this sort of mathematics going on behind the scenes. This is an orthogonal projection. It's called the orthographic map projection. And the orthographic map projection is also known as the world from space map projection. And you've probably seen this being used in illustrations and things like that. And one of the things that we can use it for is that, you know, and this is me putting an idea into your head or putting a flea into your ear, is that maybe if you attempted to make a locality map like this, let's say you've got a project that covers Western Australia, and you attempted to make a locality map like that, consider instead making a locality map like this using the orthographic projection. We can take the orthographic projection, we can manipulate some of the parameters, and we can produce something more natural looking like that. I mean, these are just ideas that bring a bit of life to your map instead of boring old, standard old planimetric mapping. Yeah. But as I said before, you know, we live in a press button world. We might be a biologist, we might be an ecologist, we might be a geologist, but we don't have any specific training in geosciences. And so we learn how to press the buttons from the videos, from the YouTube videos that QGIS put out, or from the Esri training materials. We learn how to add data. We learn how to, you know, do basic symbolization. But beyond that, we don't know what we're doing. Okay, so we're living in a press button world. And I think it's important that when we are professionals, and we might be the, you know, the science professional, the biologist, the ecologist, I think it behoves us to, you know, to dig into the science and techniques of cartography and mapping a little bit more than what I think we currently do. And, you know, I was reading this little known philosopher, his name's Rudolf von Schiesenhausen. He had this idea of the threshold of mediocrity. And the threshold of mediocrity meant that when you have automation, when you automate things, you take away the need to have knowledge. And so domain knowledge drops off or atrophies as automation increases. So you can have a GIS system that does good mapping, capable of good mapping. You don't need to know so much, or you can get away with not knowing so much. But in actual fact, you increase your risk of screwing up. Okay, so Schiesenhausen, I don't know how to pronounce his name, Schiesenhausen threshold of mediocrity. He said there is a point at which you can cross with automation where your risk of making mistakes increases drastically. So that's, you can Google, it's hard to find him on Google actually. He's not very well known, this fellow, but he's quite a wise fellow. That's my alarm telling me I've got 5 minutes to go. I wanted to show you a couple of things. There's some blogs you can go to if you want to get ideas. It's always good to steal other people's ideas. And Marcus is going to share the URLs to these blogs later on. But this guy here, John Nelson, he's an absolutely inspired cartographer. He has a very prolific blog presence, and he's always putting up tips on how to do things, how to do these sort of maps. If you want soil data, you can go to the NUS Map Library online. They have a very good system set up there, and if you go to the this URL, you find a map you like, you can click on this and just open it up in ArcMap, and the georeferencing is very good. We often use this for source data. And now, what I want to do now is just quickly show you some other stuff, just to close off. So, throw ideas out. Here's a map of Upper Pierce Reservoir. Okay, so the map basically is a polygon. Turn off the surf. It's basically just a polygon of the reservoir, shaded blue because water's blue, right? So we're going to make a blue reservoir, and around it we have some forest, and we have some streams in the forest that's in the Central Catchment Nature Reserve. So that might be our map that we might produce for some sort of project. But you know, it is rather boring, isn't it? It's a rather boring map. You know, this area is quite hilly. Maybe we want to show the hills somehow. So we might put contours on. So they're the contours. I know Uncle Nick likes contours, but I feel that contours put too much line work on the map and make it too busy, make it difficult to read. I think that unless you actually need contours to actually read, you know, what is the actual height of the ground, there are other ways to depict elevations that I think are much better. And I prefer to use the hillshade. So I've got a digital elevation model behind. I built a digital elevation model, which is basically a raster data set with the heights georeferenced on it. And I ran a process called the hillshade, which puts the sun at a particular location and produces shadows and light on the data set. And I put that behind the forest and the water. Basically, I put it behind the forest. And what happens is it gives you this 3D effect. I don't know whether it's coming across on the internet, but it should be giving you a sense of 3 dimensions. It's much more useful, I feel, to depict elevations and make the map more interesting and make you want to have a closer look at the map than contours, which clog up. The other thing I've done is here, instead of having just a boring old blue lake like that, because I've got the digital elevation model sitting behind there, if I just make that layer 40%, 50% transparent, I can get the concept of depth on that lake. So there's some of the things you can do to make your maps look more interesting. So the digital elevation model, it's not something that comes for free. You have to work hard to produce one of these. You need to take some existing topographic maps and digitize the contours, digitize the streams and the ridge tops, and then you do some processing and you can produce something like this, right? So it's pretty interesting. You can even go underwater with it. Oh, it's a bit difficult to drive it here on this screen. There we go, going underwater. See? Cool, eh? A lot of fun. And of course, you know, you can also, you don't have to make planimetric maps. You can also, you know, make 3-dimensional maps. You can put a 3-dimensional map into your reports. You don't have to have these boring old planimetric maps. Yeah, so it's now time for me to stop talking. One of the things that I was talking to Marcus about is, you know, we can't do much in 20 minutes. In 20 minutes is just a bit of ideas being thrown around. We're thinking about putting on a workshop for people who are actively using GIS either QGIS or ArcGIS. I think most science students are using QGIS. And we might run it over a weekend, and we'll prepare some data, and we'll do some maps and stuff, and we'll use it as a training exercise. Because I think that the students need a bit more guidance when I see the sort of maps that are turning up in scientific publications. It's clear to me that the students coming through into the scientific community probably need a little bit of extra guidance on cartography and mapping, the art of cartography and the science of mapping. And I think that we should be able to give that. So keep your eye out. Marcus and I will organise that probably for the semester break, for the NUS semester break. So watch for that. So Marcus, I'll hand back to you, mate. I'm done. And I'm ready to address questions.
Awesome. Thank you very much for the talk, Tony. That was very interesting, and I enjoyed seeing all of the art that was shown, especially of the really weird whales and stuff. So we got a couple of questions now. So I guess let me just get back to the top. Let's see. Yeah, so Audrey wants to know, what are some common ways in which you can manipulate modern maps? And if you think that the Mercator map is the best way to project the world?
No, I don't think the Mercator map is the best way to project the world. The Mercator map was designed for navigators, and it does not render the pole areas anywhere north or south of 70 degrees, north and south, cannot be rendered effectively and properly on a Mercator map because of the way the cylinders project onto the plane of the map. If you look into the software, I mean, I think that you can go into either QGIS or in ArcGIS and look at the different sort of map projections. There are hundreds of map projections. There are world map projections. There are state map projections. There are country map projections. And you can choose from those. You know, if you opened up an atlas, if you had an atlas when you were at school and you had those, you know, fancy looking maps, you can also produce those from the GIS, and those are available. And if you, I'll just open up this part here. If you just right click data frame properties, I'm in ArcGIS at the moment, the same thing, similar thing happens in QGIS. Got all these these are all the map projections that are available. So in the projected coordinate systems, we have these world coordinates, we have all these different ones here to choose from, and you can just play with them. You know, just go in and choose the map. But the Mercator map projection is not a very useful map projection. And furthermore, when you are displaying data on your screen, particularly if you've got geographic data, it's not really a proper map projection that's coming onto your display. You should really work with a proper projection. And, you know, this pseudo Mercator that QGIS produces is a load of nonsense in my view. You need to actually pick a proper map projection. So if you're working small scale, you might use SPY 21 in Singapore or GDA 94 in Australia. Or if you're doing large scale maps, sorry, small scale maps of the world, then you go in here and pick Bonn, Cassini, Miller, you know, these sort of projections, which are much more appropriate map projections to use for maps of the world. And if you want to produce these, you know, Earth from space, use the orthographic map projections, which I think are in this list also, if I'm not wrong. Yeah, so there's no end to what sort of manipulation you can do on a map. It's infinite.
Okay, the next one is from Sexuan and Uncle Nick. They want to know about the depth data for the reservoirs in Central Catchment Nature Reserve. So how up to date are these data?
Well, you know, I get this data from, hang on a sec, the Zoom menus are covering up my menu. I go to the Singapore libmaps.nus .edu.sg, and I can go into, say, let's say 1945, any time before a reservoir was built, right? And I can go to the reservoir. Well, Makritchie was built in the 1800s, so it's hard to get a GIS of the elevation set of that map, of that reservoir. But here's the Upper Pierce Reservoir, and you can see I can get contours of the Upper Pierce Reservoir before it was built. I can go back to 19, or the 1924 maps are not here. The National Archives have 1924 topo maps, and that's where you'll get much better contours. But basically, you've got to find a topo map that was created before the reservoir was built, and then you can build up the digital elevation model like that. And sometimes you have to search around, scratch around, and you have to be clever about how you georeference it. And it's a lot of work, and but it's really valuable. You know, you can just dump your shape files into ArcMap and hit the print button, and you'll just produce mediocre maps. If you want to produce really nice maps, you have to be prepared to put time and effort into it. And building a digital elevation model of the subsurface of the ground, you know, underneath of a reservoir, as well as the, you know, the terrain around it, is, you know, a few days work for, say, Central Catchment Nature Reserve.
Okay. I think that's all the questions from me now. You got anything, Marcus? I'll unmute him. That helps.
Yep, no specific questions because time is almost up, but we've got several feedback from the chat saying that they are all looking forward to a QGIS workshop. So I think Tony and I will have to work hard at this, try to organize something for people who are interested, especially for the with a local context. So akan datang, right? Hopefully somewhere in September. Yeah. So thank you so much, Tony, for sharing with us your thoughts about how to put the art back in cartography. I'm going to unmute everyone as usual so that we can all thank Tony. So I'm going to be unmuting in 3, 2, and 1. Thank you, Uncle Tony.
Thank you, Tony. Uncle Tony.
Thank you.
Thank you.
All right. All right. So as usual, people stick around because now we'll be proceeding to the trivia section. Shortly.
Yep. So while that happens, I'm gonna paste the trivia Google Sheet in the chat room for everyone so that you can update, put in your team name as well as your selected beneficiary while we start sharing our screen to talk about how the trivia is played, especially for all our new participants this week.
Yep, of course we got a lot of new people, so we'll go through the whole works of it.
Yep, so please head on to the Google Sheet I just posted, tinyurl.com/sgslam-trivia to fill in your team name as well as beneficiary. So Kanan just started sharing his screen.
I was having some technical difficulties and I could not find the window.
Super. So how we play the trivia is that, well, we have 4 rounds, including 1 bonus round, and this week's theme is MSE because of the newly named Ministry of Sustainability and the Environment, and a bonus round. So everyone, please update live Google Sheet. I see some names already in added to the live Google form. So how we're going to play this is that the questions are going to be flashed on screen, and you can write them down on a piece of paper, your answers, or you can put them on, you could type it out on your phone, or you can put it on an Excel sheet. At the end of the trivia, we're going to go through the answers and you can mark your answers yourself. But what we require of you is to send us either a photo of what you've written on the piece of paper or email it, your answers to us, and that's how we check. And that's, after checking, we will review the official winners, right? So that's what we're gonna do. So hold on to the edge of your seat. You can play this on your own, or you could set up a team with your families and friends, or you could play with virtually with other teammates. But the important thing is that the honor code, no checking of answers on from books or from the internet, right? So this is optional. Everyone's encouraged to contribute $1 to the trivia pot, and the winner today will decide who will benefit from it. So the note is that till the end of this year, the Singapore government is offering a $1:1 matching for all donations. So our charities benefit from this. So I'll be ready to begin.
Yep. How are the names looking? Are we good to go?
I think we are good to go.
Awesome. So for M is a no-brainer, maps. The first topic is maps, cause duh. So oh, there we go. To obtain images of difficult terrain, let me just minimize this. Difficult terrain, Google Maps sometimes attaches a camera to a trolley, a snowmobile, a tricycle, or even a camel. True or false? True or false? Google Maps sometimes attaches a camera to a variety of cool methods other than just their car. Okay. Moving on. Despite being 14 times larger, Africa is often portrayed as the same size as blank on the Mercator projection maps. Despite being 14 times larger, Africa is often portrayed the same size as blank on the Mercator projection maps.
Are we looking for a landform here?
We're looking for a country, not a continent, a country. Yeah. And the image is of when all the continents used to be one, the good old days. All right, moving on. Oh, by the way, right, if you guys need any questions repeating or reflashing, just shout us on the screen, on the chat. Which of the following disease outbreaks was halted with the aid of a map? Which of the following disease outbreak was halted with the aid of a map? A, the Black Plague, B, cholera, C, Ebola, D, COVID-19. Which of the following disease outbreaks was halted with the aid of a map?
Where's this map showing?
The country where this happened.
Hint, hint.
Yeah. There have been indications of maps being present from the time of cave paintings. How old is the oldest known record of a map? There have been indications of maps being present from the time of cave paintings. How old is the oldest known record? Okay, moving on. The last one, what country does this map show? What country does this map show? I see that some of you having the right idea.
Yep, I see Sichuan turning his head around.
Yeah. I mean, could it be upside down? Could I have inverted it? Could I have stretched it out? Was this landmass really a circle? No one knows.
Yep, it looks like an avocado to me.
Yep. All right, moving on. S stands for spermology, and it's not what you think it is. Spermology is the study of seeds. Give me one example of an Australian plant that requires fire to aid in its seed germination or dispersal. Give me one example of an Australian plant that requires fire to aid in its seed germination or dispersal. You know, Marcus, when I was making the questions up, right, I realized that instead of spermology, I could have just put seeds and it would still have been fine. We could have still done the MSE thing. And I was like, it's okay.
And see ya.
Yeah. All right. Moving on. I have a few answers for this. So later when it comes to it, if you guys have an answer that's not on the list, let me know. Because I kind of did a quick research last night. So yeah. Give me an example of an adaptation found in seeds that depend on animals for propagation or dispersal. Propagation. Give me an example of an adaptation found in seeds that depend on animals for propagation or dispersal. Farmers chucking them out is not one of them.
So adaptation in this case has to be a change in structure of the seed.
Yes,
So
yes, morphological adaptation. Okay, moving on. Apple seeds contain amygdalin, which in large doses can cause cyanide poisoning. How many apple seeds on average are needed to result in the cyanide poisoning of a human adult?
I hope this question is not giving people ideas.
Oh, it won't be, because I'll tell you why later. Because apparently with like all the new cultures of apples, right? Some of them have been bred to have like lower levels, and some apples have far fewer seeds as well. So you may need to eat a lot more apples to get through to the number required.
Several accidentally swallowed.
And there's also the ingestion method as well. So yeah. What living plant produces the largest seeds? What living plant produces the largest seeds? A, the agave cactus. B, the avocado. C, the sea coconut. And D, the normal coconut, common coconut. Oh, by the way, for the previous question with apple seeds, right? We will take plus minus 20. We'll give you half a mark if you get plus minus 20, and we'll give you the full mark if you get the exact one. Hey, it's like the minimum number you got to hit, but like I say, the number kind of varies a bit, so yeah. Because I mean, if you're going to go for poisoning, you can eat literally like 1 billion seeds, right? Go for it, why not? But we are looking at like what's like the average minimum we need to hit. Question 5, for spermology, the oldest known mature seed to germinate is a Judean date palm from Israel. Approximately how old was it? The oldest known mature seed to germinate is a Judean date palm from Israel. Approximately how old was it? A, 1,000 years old. B, 1,500 years old. C, 2,000 years old. And D, 2,500 years old. 2,500 years old even. By the way, the question wants to know the age of the seed when it was, before it was germinated, not like how old the plant was when they found it.
The plant today is about 15 years old because it was germinated in 2005.
Yep.
So apparently it's a small tree now.
I would look at pictures of it and I was like, that doesn't look very special, but okay, cool.
Sikhan said that he was told by his mom if he ate an apple seed, an apple would grow up, tree would grow off his head. I think we were all told this by adults at some point when we were young.
See, I used to believe that as well, and as a child, I accidentally swallowed a rambutan seed. The following week was like the scariest thing. Every time I had like a slight pain here, I thought it was taking root right in my rib cage. So yeah, I tried to throw up and it never came out. So I was like, great, that's it. I'm gonna be tree boy. Right, for E is aeromology. Aeromology is the study of deserts. What fraction of Earth's landmass is desertified? What fraction of our global landmass is desertified?
I suppose you could give a fraction or a percentage.
Yeah. I mean, you can drop a fraction, but if you want, you can drop it as a percentage as well. Or you can spell it out if you don't want to use numbers as well, because I think we would be able to guess what it is. So yeah. Okay, moving on. What is the world's largest desert? What is the world's largest desert? Marcus, I feel like we have asked this question before, but I'm not too sure. And I was like, I didn't go and check the previous ones, but I feel like we've had this question before in one form or the other.
Maybe, I don't think so. I'm not sure.
Yeah, I'll check. I mean, if this question has been on before and if our regulars do not get it, no pressure, guys. No pressure at all. All right, moving on. The Atacama Desert in Chile has parts that have never been touched by rain. True or false? The Atacama Desert in Chile has parts that have never touched rain. True or false?
I suppose the insides of a mountain has never been touched by rain.
Pardon?
the insides of the mountain range.
Ooh, I don't know. What if maybe the insides were never touched as well?
Nah.
And
Ooh.
question 4, how much land do we lose annually to desertification? How much land do we lose annually to desertification? Apparently this video was of a desert somewhere. I mean, it said it's a desertification video, so I thought it was one of those things where the water source starts shrinking down, but it's not. But I thought it looked cool, so I added it in.
So Sidway's asking percentage or fraction for how much land we lose, or are you looking for an area?
We are looking for area, so give us like in square kilometers, hectares, acres, miles, square kilometers, yeah, that kind of thing. Don't go square meters or something too small though. Okay, and moving on, last question. Which is the larger desert? The Gobi Desert in Asia or the Mojave Desert in North America? Which is the larger of the two deserts?
Be interesting to see people's answers for this one.
Mm-hmm. And also I learned that the Mojave Desert has got nothing to do with the Mojave rattlesnake. The rattlesnake comes from a different place, which is why it's spelled with a H, not a J. That was like one thing I learned from uni, and I still remember. One of those fun facts I learned, because people are like, oh, is it because it's a desert? And my lecturer is like, nah, it's somewhere else. I think it's a place or someone's name, but not the desert itself. Righto, moving on to answers. So for those of you who have never played before, what we'll do is we'll do the 3 topics, and then we'll do the answers for them. And then we will move on to the bonus round, right? So don't worry about sending answers in now. We will let you know when we need your answers. So don't spam our emails yet. So answers for maps. True, they do put their cameras on odd things to get maps everywhere. When my friend Lydia was doing in Panama, when we're looking at a site, it was done by a guy on a bicycle on a selfie stick. And when she was there, she actually met the guy as well. So yeah, that was fun. So yes, they do camels, snowmobiles, tricycles, bicycles, people walking on foot as well. Despite being 14 times larger, Africa is often portrayed the same size as Greenland on the Mercator projection maps. Greenland is the answer we're looking for. So Greenland is supposed to be really tiny. And question 3, cholera was halted. And it was done by a guy called John Snow. So apparently John Snow knows something. So he managed to track it all the way down to a single water pipe, which was where all the cholera cases came from. And he actually managed to stop cholera outbreak in the area, and they managed to spread it all over the city. So yes, cholera is the answer. I'm not sure which the year though, I don't remember that. And the oldest cave painting, no, the oldest map is 16,500 years old, which was found in a cave, and it was a star map. So people were into star tracking, and they did a star map 16.5K years ago. And this is the map of Sri Lanka, which I turned on its side for fun and to torture you all. So yeah, thing is, I do not know whether another country looks the same on its side. So if it does, sorry, not sorry. And answers for spermology. Some of the examples that I could find were the eucalyptus, the Australian grass trees, or Banksia. I think Banksia is the genus. So if anyone else has got anything else other than these, let us know in the chats and we will look into them. But the ones that I managed to find quickly were eucalyptus, grass trees, and Banksia. And to be propagated or dispersed by animals, you need to be covered in sweet fruit. You need to have barbs, hooks, or teeth, or burrs to get attached to animal fur, clothes, and stuff. And need to have food benefits like hazelnuts, where you are a tasty seed and animals may want to hoard you for later. So any of these or any version of these counts. Moving on. You will need to eat at least 180 apple seeds to result in cyanide poisoning. So if you got 180, we'll give you the full mark. If you get anywhere between 160 to 200, we will give you half a point. But like I say, right, like a couple of seeds won't do anything to you. So if you're one of those people who eats the cores, carry on, unless you're eating a large number of apples in a day. And the largest seed belongs to the sea coconut or the coco de mer. I think the biggest one was like 45 kilograms or something. It's also known as the double coconut. Of course, it's like two coconuts stuck together. So, yep. And the last one, that is the picture of the Judean date palm, which grew from the seed. And the seed was 2,500 years old when it was germinated. So Marcus, was this just a dormant seed or was this found in one of those like archaeological sites?
It was found in the archaeological site, and the reason why scientists think that it could be it survived for so long is because it was kept in a cool, dry place. Okay. So I think the whatever is said on your food packets is a good recommendation. So
I guess it must have been part of like a seed store in a kitchen or a larder, right?
Oh, I can't remember where it was found though, but it was found in an archaeological site that was somehow preserved for a long time.
If it's a seed in an archaeological site, I would think it's, you know, in a cool, dry place. It's probably from like a larder, people keeping it cooking or something. So yeah. All right, off to deserts. A third of our landmass is desertified, which apparently desertified is not a word. I just made it up for desertification.
So 33% can, Sinway.
Yes, 33%
Better still,
can.
33.33332.
Also can, 1/3 can. You can just put THIRT.
What's the error bar on that? Error bar.
I don't have an error bar on that. I didn't think of an error bar because it was a fraction. So yeah.
Because I'm pretty close.
What do you get?
I put 33. So I put 30%.
Yeah, yeah. You know what? If you guys put like 30.
5% maybe.
Yeah, 30 to 35. We'll give it to you. 30 to 35 works as well if you got a percentage going on. Question 2, the world's largest desert is Antarctica. It is because it never rains over there, and also to be a proper desert you need to lose more water than you gain, and apparently Antarctica loses more water than it gains. So Antarctica is the world's largest desert. So penguins are desert animals.
So when I was researching the question there, so when you put the answer, I was like, oh, there are cold deserts and there are warm deserts.
Yes, there are cold and hot deserts. And yes, there are some parts of the desert which have been dry for over 40 million years. So I guess, Marcus, there are some mountains which would be untouched on the inside as well as the outside. So there are some parts of the desert that have been never touched by rain for 40 million years. Nice. And yes, this is all the numbers. So if you guys got anything close to this, right, round it off to like the nearest 1,000 or the nearest million, we'll give it to you. So if you got like 12 million hectares, 46,000 square miles, 120,000 square kilometers, or 30 million acres, we'll give it to you. And shall we give a 10% of cut off markers on either side for half points?
Wow, that's hard. You mentioned 1,000, right?
Yeah. So like for 46,000, oh yeah, 10% squared. 10% should be fine, I think. Is it not?
Okay, sure.
Yeah, we'll give 10% on either side for half a point. If you guys get it close or to round it up, we'll give it the full one. Because I realized that the numbers were quite big, so yeah. But this is how much we lose annually. Oof. And last question, the Gobi Desert in Asia is the larger of the two deserts.
Yes, by far. Although the Mojave Desert is the third largest desert in North America.
Nice. All right, bonus round.
Yeah, so Marcus, please tally all your scores for the 3 rounds and put it on the Google Sheet. So we would sum up all your scores with a formula for you. And from here, we will decide how we're going to play the wager.
Marcus, do you just want the number we got right, or do you want the whole list?
The number you got right.
Okay. For
this part. So just put in your scores. Later, we will ask for the whole list to be sent to us. Right, so I see movement in the Google Sheet. People are updating it. So if you have difficulty accessing the Google Sheet, you could just read us your scores and I could update it. Oh, I see. Everyone's putting it. Super. Okay, so how the wager works is that you tally and you wager your points. You can wager from 1 point to the maximum number of points you have. So let's say you got all your questions correct, you got 15 points, you can wager 1 point to 15 points. And how it works is that you gain the number of points you wager if you are correct. So if you got the answer correct and you wagered 15 points, you will get 15 plus 15, 30 points in total. But if you get it wrong, you end up with 0 points because you lose 15 points, right? So fill up your wager amount on the Google Sheet and the wager column. And I see almost everyone has filled up the wager and everyone's going for broke, it seems. So as usual, to this bonus question will be based on the talk. So you're all listening intently to Uncle Tony because everyone has filled up their wagers. We would review the bonus question. Go ahead, Kanan. Oh, you're muted, Kanan.
I am muted, I'm sorry.
Okay.
Bonus round. According to Tony and early cartographers, what do sea serpents eat? According to Tony and the early cartographers, what do sea serpents eat?
There was even a picture of sea serpents and Tony's
Yep.
map, it was illustrating it.
Stuff, yeah. Oh, I didn't mention earlier, when you guys are like wagering your points, right? You can only wager what you have won so far. You can't willy-nilly throw stuff in, so yeah. How many teams do we have, Marcus, while people are trying to figure out?
We have 6 teams playing today.
Nice, excellent, excellent.
So we have a former winner, anonymous Malayan water monitor, who's in as well. So
yeah. Earlier we were talking about it. You should probably change it to like anonymous whale shark, keeping it with the trends.
I think he prefers his Varanus.
Yep, definitely.
So I think that's enough time for everyone to fill in the simple diet of sea serpents.
Yeah, have they filled in the Google Sheet as well? Yeah.
Yep, they're all filled in.
Okay, excellent. So sea serpents eat semen. Sea serpents eat semen or sailors.
Okay.
You know, if I prefer their other name, but yeah.
Yep. So Uncle Tony mentioned this a few times. Sidwa said people. Yeah, people, we accept that.
If you get anything else other than semen, we'll give you half a point.
Okay.
Yeah. Well, I mean, we'll give you the point, but if you say semen, we'll give you an extra point. So yeah, because that was the answer we're looking for.
Super.
Yeah. So if you say sailors or people or anything of those sorts, you can get it. Seaman gets an extra point. Okay.
Okay, so please update the Google Sheet. If you got the answer correct, you add the number of points. If you get it wrong, you minus the number of points. And if you got the exact answer, you add 1 more point to your total point.
Yep.
I see CG has got it, got the bonus question
and also,
and the word correct.
Send us pictures of your answers to sgstem.talktrivia@gmail.com. So the reason you guys send us the answers, right? Because right now Marcus will look at the Google Sheet, give us the unofficial winner, and then over the weekend we will look through all the answers and we'll announce the official winner. And so far our unofficial and official winners have been on par, have been the same. So yeah, just send it to us to make sure that everything is all good.
Okay, so this week it's the second time we're having this situation. It seems that 2 teams or 2 people have got the same grand total score of 20, and that is SSW, the Raffles Banded Langur, as well as Anonymous Whale Shark. Right, so one of the beneficiaries is JGIS for SSW, the Raffles Banded Langur, and Acres for the Anonymous Whale Shark. So how are we gonna do a tiebreaker, or do you want to divide the beneficiary by 2? So
I did not think about tiebreaker question. Okay, what shall we do? I think we'll do a tiebreaker, Marcus. Do you want to throw a quick tiebreaker question?
Wow.
Yeah.
Okay, let me think of something real quick. So Sidway suggested splitting the pool money.
We can split the pool money. We don't mind. If Anonymous Whale Shark is okay with it, we can split. Because you guys are the winners. If you guys are okay with it, we can split. Or if you want to, okay, yeah, if you guys want to split, we can split it. Or if you guys going to call for a thingy, split tiebreaker, we can do that too.
Yeah, how about that?
Yeah, if Sinway and Ivan are both okay with splitting, we will split this week's funds, half to ACRES and half to JGIS.
Super. So, all right. So this is our unofficial results while we check our emails for your answers. But congratulations to Sinway and Ivan for your efforts today and everyone who's participated. So still not too late to contribute to the trivia pot. So this the instructions are on screen.
Yeah, the details are here if you want to donate for the trivia pot for this week, where half of them, like Marcus said, is gonna go to ACRES and the other half is gonna go to JGIS. Right.
Don't run away yet because we're gonna talk about the next SGSTEM session, and right on the topic of sea serpents and sea creatures,
and
we have Miss Katie Shi from the Dorsal Effect. And Katie is a shark enthusiast, and she's gonna talk about shark tagging, right? So also on the theme of whale sharks and spotted in Singapore's water, is it like putting a permanent price tag on a shark, right? So Katie will share with her experience of tagging sharks off Florida, as well as in the Gulf of Mexico with shark scientists, and the importance of science and tracking of sharks in the ocean for conservation. Right? So she's very active in shark conservation as well. So join us. There's the link for the registration is already up. So
yeah, I'm just going to put the link in the chat as well. So yeah.
On 27th August and Thursday, same time, 8 p.m.
Yep, and that is us, I think. Awesome. Yeah, I've put the link up. The link is live. The link should work as well. Should it not, you guys know what it is. It's SGSTEM and the date of the talk, which is 27 August. So we will see you guys in 2 weeks. Oh yeah, Marcus, do you want to grab the Wi-Fi?